Hello guys, I'm Sandip, and so we are going to start your last chapter of the physics, right? So the main portion of the syllabus is, I hopefully it's already over, but you already know about the forces or electric charges, or we can say light, right? You must have studied all those things. So if you already know the lot of physics, so this chapter is going to be very easy and theoretical chapter, right? So we don't have to apply a lot of uh, you can say logic in this chapter. Only theoretical chapter, just remember the concepts and that will be it, right? So so today's chapter name is sources of energy. Right. So you already have studied about the work power energy most probably. Right? The chapter work power energy. We have to do some work, obviously we need some energy. And what are the different types of energy you have studied? I think you must have studied the kinetic energy and potential energy. So kinetic energy is what? At energy of any object we can say. Due to what? Due to its motion, right? So if the object is moving, it has some kinetic energy. Then if object is kept at some particular height, we can say it has some potential energy. So very simple thing you can do. You must have studied this in the work power energy chapter. Simple. If this is the pen, if you put this pen, let's say a little bit higher, right? So consider, let me take the reference point. So consider this is our ground, right? So pen is on the ground. So it has, let's say, potential energy 0. So when you are taking it upward, what you can say? That now this pen will have some potential energy. You also know the formula, that is EMG. Okay. Now it has some energy, so can it do some work? Yes, obviously it can do some work. Right? How it can do work? So obviously, if you release this pen, I'm holding this plane, therefore it is like this. Right? If you release the pen, what happens? You can see that drops. How it drops? Because it has some energy. Every body, every object, remember always this concept is very important for your entrance examinations after 11, 12 also. Every object is going to try to achieve minimum potential energy. So this pen never wanted to be here. It always wanted to be on the ground. So if you release that, it will come back to ground. It tries to achieve the minimum potential energy. Okay, good. Now if it is doing some work, obviously we also know that energy can never be created, cannot be destroyed. So if that potential energy is changing, we also know that part, that potential energy gets changed into the kinetic energy. So we get the kinetic energy from that. Okay, so these are some types of energy you already have studied. But now, what are the sources of these energies, right? So obviously if you want to do some work, suppose I want to speak, right? Speaking is also a work. I want to walk. Yes, that's a work, right? I want to pedal the bicycle. Is it a work? Yes, is it a work? It's a work, obviously. So if you want to do work, some work, we need energy. Who is providing us the energy? Yes, think on that. Yes. So we got our energy, which we can use to do some work, right? We get the energy from the food particles. And who is producing? We cannot produce the food, right? Or it's not like that we can get the energy from the sun, that whatever heat we are getting, we can convert that to walk. No, we are completely dependent on what? We're completely dependent on food, and food is created by the trees. So we are dependent on the trees. So we already know that trees are the very important part of our life, right? So trees not only provide us food, but it also provides us oxygen, which is so two important parts which are essential for our life is provided by trees. Okay, so we know that thing, right? Good. So energy which we are getting from the food, and in food there are many things we can, carbohydrates we can say, right? So carbohydrates are providing us food, energy, and we use those energy in to do some work, muscular work, right? So we actually we that we can say energy we are getting from the food, we convert it into muscular energy or muscular work or muscular force we apply and do some work for writing or walking, running, jogging, etc. Okay? Or speaking also, obviously. So obviously when I'm speaking, I'm spending some energy. Right? So that's it. So these are the energies which is required for us, right? Human beings require some energy. Now let's talk about the machines. Consider you have the TV, you are watching the TV, right? It needs the energy. Which energy it is consuming? It is consuming electrical energy, right? So can I say electrical energy is the source, right? So yes, we can say it is the one of the source of the energy. But we actually create, the humans actually create the energy. So there are two types we can say. One of the type we can say is the nature gives us some energy, and one of the energy we can say we create some energy, right? So yes, so what are the natural energies you can find? Very easy to understand. You are studying this from I think fifth, sixth standard only. That solar energy, sun is providing the energy. That is totally natural energy, right? We know that it is not going to end in near future. Obviously, sun will also have some uh, lifetime also there, right? You must have studied that in, I guess, in previous standard of stars and planets chapter, right? That sun also have some lifetime, but comparing to our lifetime, it is very huge. So we don't care. Normally, we say that sun will provide you the infinite energy for infinite time. It is not going to end, obviously, right? At least for our humans generation, we can say. So as long as humans are there, sun is not going to stop mm, giving us the energy. So we can say solar energy is the renewable energy, means it is not going to end. What are the different other energies we know which are not going to end? Can I say wind energy? Right? Wind energy is the energy which is not going to end. Wind will always flow. So how we can use that wind? How we can take the energy from that? So now we know normally in our daily life, the most energy we do use is the electrical energy. Right? Everything around us is working on the electrical energy only. If there is no light, there is power cut. We don't know what to do. Once our mobile goes mobile dates, battery dates, then we don't know what to do, right? So that is very important part of our life. Everything, every instrument, laptop, mobile, TV, washing machine, freeze, air condition, everything is running on the electrical energy. So what we can say, for us, electrical energy is the important source, right? But actually it is not like that. We are getting energy, electrical energy, the natural source. No, we have to create, we have to generate that source, right? So who is generating that source? So we can use actually the wind there, wind energy is there, or water. So you must have heard that wind turbines are there or water turbines are there. Those are actually creating the energy. You must have heard a little bit about that in your electrostatics or electric circuits chapter, that in the power station they use that wind turbines to create energy. Wind turbines or power, there could be water turbines, like those. Then what are the different forms of energy we need actually? Electrical energy does a lot of our work. Food we need for our own energy. For instruments we need the electrical energy, right? Then for our cars or bikes, which energy we do need? We need the fuel, right? That is also important. Petrol, diesel, right? So many times petrol, diesel's prices got high. There rises, right? So there's a very big issue in any country, right? That power of fuel is increasing. Now that fuel we are talking about, where that fuel we are getting? We are getting that fuel from the oil companies, right? So oil companies means there must be some oil there, then only we can use that. Yes. So those oil, as we say that the sun energy or wind energy is renewable. Renewable means it is not going to end, right? Obviously. But this oil, it is petrol, diesel. Obviously, it is going to end sometime, right? So it has, but obviously we can say it's not in near future, but we have to use them properly, right? Save them, save oil or save petrol, save diesel, try to use less of oil, obviously, all right? And it will also save our money, because nowadays petrol diesel's prices are getting very high and high, right? So obviously some companies like Tesla, we can say Tesla is working on that electric cars, electric buses. Nowadays, in many countries, that electric cars, electric buses are there, right? Which do use the electricity as the source instead of petrol and diesel to save that oil, right? Because yes, oil is not renewable; it is going to end sometime, right? Okay. So these are some sources of the energy. So now let's see what else we have. So what we are supposed to cover in this session is the different forms of energy, and what is conventional and non-conventional sources of energy, and fossil fuels. So here you can see that some small diagrams are there. They are actually representing some types of energy. So I can say this is the thermal energy, right? Thermal energy means heat. Heat is obviously giving you some energy, right? As sun is giving us the heat. Similarly, if you burn that coal, wood, we can say, wood is also going to give you some kind of thermal energy, right? Can we use thermal energy anywhere? Yes, obviously we can use the thermal energy, right? Not only wood, but we can also burn the coal, right? So coal is also a very big source, right? Natural source, we can say, but it is again not renewable. So there are many coal mines and all those things are there, so to get that coal. But once the coal mines are empty, what we are going to do, right? So we have to depend on that solar energy, wind energy, which are never going to end, right? So this is the one part, we can say, wood is burning, we can say, and we are getting the thermal energy. What is this? This is a fan, right? But not our normal fan which we use in home. These are actually the wind turbines. I told you about this, right? Wind turbines. So because of the wind, these turbines are going to move. So what we do, if you want to run the fan in our room, in our home, we switch on the light. Which energy is running that fan? Obviously electrical energy. Where we are getting the electrical energy? In the power stations. What is there in the power stations? These are the bigger fans, we can say, and these bigger fans are not rotating on the electrical energy, those are rotating because of the wind energy, right? And so what we are doing actually, if you consider it, uh, you can say in our home we are using the electrical energy to move our small fans. These are the very big fans. We cannot use the electrical energy because we are actually creating the electrical energy by that, right? So who is going to move those fan? Wind energy. So wind is doing some mechanical work and we are getting electric energy. And in our home, we are using electrical energy to move that fan, means to do some mechanical work. Right? To rotate fan means what? Mechanical work is there. Right? So this is the wind turbines energy. Right? These are the power stations where using the thermal energy or some natural gases or oils, we can get some energy. This is our petrol, important part, another important part of our life, right? We cannot run out of the petrol, so we need to use bikes, car. So always our tank should be full, right? We know that part, but again, as I said, we should save the petrol because anyway, it is not a renewable source, and prices are anyway going to rise. Okay, then this is the very simple, you can say, matchbox. This also creates some energy, light energy. You can say if there is no light, we use the candles and etc. We use the light energy, heat energy. Right? This is our electrical energy. Actually, this wind turbine is going to create this electrical energy. And what is this? It looks something like a solar panel. So this is the very easily available energy. But actually, why we do not use a solar panel? Because we know that sun is only for the day there, right? So we have to store that energy. In night, it becomes difficult to use that energy. Also, what we will do in rainy season. Rainy season, most of the times clouds are not allowing the sun rays to come. So that solar energy is obviously not easy to use, recollect or store. It is very costly actually. Nowadays, it is costly. Therefore, we use this electrical energy or other energies, that petrol and etc. Right? But yes, in the near future, we can expect that the cars will run on the solar system, right? That would be very nice. That because there will be no pollution in that case. Right? These are some conventional and non-conventional sources we can say. The next point we are going to cover is the fossil fuels. Fossil means already we have talked about this, that oil, or you can say natural gas, or you can say coal. All those are the fossil fuels. Okay. So you could have understood the concept that solar energy do not pollute anything, but the oil, petrol, diesel, or you can say coal burning, right? So all these things actually create the pollution, right? So which are good one? That our solar, yeah, solar panels are good one. Wind energies, wind do not create any pollution, right? So those are the good ones we can say. And those are renewable, they are never going to end. But fossil fuels, yes, oil is going to end, coal is going to end, like that. Okay. So let's go into the detail now. So, so what are the different forms of energy? So we have already seen some of those. So here they have listed the different forms of energy. So thermal energy is there, radiant energy is there, chemical energy, nuclear energy. Now nuclear energy is also the very big part of the energy. Now you must have heard the nuclear bomb in the Japan, right? Hiroshima, Nagasaki. It was very long time ago. We were not even born that time, right? But those nuclear bombs are still, every country have those nuclear bombs, right? But there is, you can say that there is some understanding between all the countries that nobody is going to use the nuclear bomb, because we know that explosions in the Hiroshima and Nagasaki were destroying. They can destroy the whole earth also, right? So hopefully nobody wants that war which will have the nuclear bombs in them included, right? Because doesn't matter how many countries, which countries, superpower or whatever, if once the nuclear bombing starts, nothing will remain, right? So therefore, every country has that understanding. So what I'm saying is that nuclear energy is very, very big, right? It's not like it is only destroying energy. We can use this energy also in the nuclear power plant. Obviously, it is creating some energy for us too, right? Okay. Then electrical energy. This is a battery. We are all very familiar with the electrical energy now. So battery can generate the electrical energy, or whatever energy, electricity we are getting from the power station, it is also generating the light, right? Okay, so this is the electrical energy. Then motion energy. What is motion energy? That is our kinetic energy actually. Kinetic energy means when any object is moving, it has some energy. Simple consider, if you consider that if you take the stone, right, and let's say if your friend is standing nearby, you just uh, from nearby you can just give him or just hit him by that stone. It will not affect him, right? It will not hit that hard. But consider if he's long away and you use the speed to hit him, what will happen? Yes, then he will going to hit you back, right? That's why it is happening, because that stone is getting that energy. Why? Because of the motion. Stone is the same, mass of the stone is same. What is happening there? That kinetic energy is going to give that stone some energy, and now that stone, when it hits the your friend, it is going to transfer all that energy into the frame, right? So that is not the good thing, right? Right. So then potential energy, we also talked about that. Here also you can see this is the apple tree, right? Is it Newton's apple tree? I don't know, right? Maybe different one. So that apple, when it is at the top, it has some potential energy. It wants to go down, right? I told you every object wants to go down, right? So that apple has potential, it wants to go down. So obviously, after some time, that falling apple will have some kinetic energy. It hit the Newton's head, so also Newton must have got some heat there, not heat, but it must have what we can say. Must have got some impact on by that apple, right? So why? Because that apple has some kinetic energy there. Okay. Then thermal energy we already know. When you burn anything, it could be wood or it could be coal, right? That gives us thermal energy. Then chemical energy. Chemical energy is also one of the important energy, right? So in this battery, what is happening actually in this battery? The battery has some chemicals inside it, and that chemical energy is getting converted into electrical energy, right? So we can actually convert uh, any energy in the other form of energy, and that is very good thing actually. That's why actually we can run our objects, instruments, bikes, cars, because we can convert that energies, right? For example, what is when we say fuel or oil, there is a chemical energy obviously. So that energies we can convert it into thermal energy inside the car. There is a heat engine and etc. You are going to study those in 11th and 12th. So those heating, that petrol energy, chemical energy is converted into heat energy actually inside the car. And that thermal energy is going to convert, we can convert those into the mechanical energy. Mechanical energy means what? Car is running. Car is running means what? That is a mechanical energy. So we can convert all those energy into each other. And that is why the whole world is running, we can say. Simple. Good. So let's move next. So different forms of energy, we already seen many forms. So let's see electrical energy. Yes, we know that part now. Thermal energy, because burning of coal or wood. Light energy. What is light energy? You have studied the chapter light, right? Right. So how to get the light energy? Who is giving main source is again our sun. Sun is giving the lot of light to us. Right? Light energy, you can say. What are the different things we can convert? We know when you use the lamp, what is happening? You are converting the electric energy into what? Your light energy, right? Then a matchbox, we talk candles. So we are actually converting those. We can say chemical energy. When we leave the matchbox, there is some chemical there, right? Phosphorus is used in that. So we are actually using that chemical energy to get the light energy. Then green energy. Green energy means nothing. It's not green colors energy, but it is a energy which actually do not pollute. We can say that, we can call it as green energy. So solar energy, yes, solar energy is our green energy, right? Then wind energy is a green energy. Then wave energy, or here you can see the tidal energy, right? So we know in ocean there are a lot of tides, right? Big tides are there. So those tides also have some energy in themselves, right? We can also convert those energies into useful energies, right? So wave energies, tidal energies, like those. Then we have heat energy. Heat energy obviously similar to thermal energy, right? When we create heat by burning the fuel, we are going to get that thermal energy or heat energy. Hydroelectric energy, again related to hydro. Hydro means related to water, we can say water and electric. So we can convert the water's energy into electric energy. Then we know the solar energy already. Wind energy we talked about. Nuclear energy. Nuclear energy means yes, nuclear bomb, but that was the destroying energy. We can also use the nuclear energy for some good cause also. Tidal energy we talked about, right? Oceans, in oceans there are a lot of tides are there. Those are the tidal. Biomass energy. Biomass energy means obviously, right? We can say biogas. We can get the gas from the biogas. You must have heard that in the biology also. Also, we are going to see that biogas thing. So we get the energy from that. Kinetic energy. It is the energy due to what? Due to motion, right? We know hit the stone to the friend, right? But not from the nearer side. We have to go long way, right? Don't do that, obviously. Then geothermal energy. Again, geothermal energy means heat due to, we can say, uh, earth also has the heat toward the center, right? So how we can use that energy? So that is the geothermal energy, we can say. Then let's talk about this non-conventional sources of energy. So non-conventional means what? Right? Which are actually directly given by the nature. So nature gives us a lot of energy. Right? So consider wind. You must have studied it somewhere in the fluids chapter. Winds or waters, those have a lot of energy, right? Water waves, tidal waves, those can actually destroy everything. You must have studied about the cyclones, storms, thunderstorms, right? Cyclones also have a lot of energy, right? If the cyclone hits also in India, there are many coastal areas. Those hit actually the coastal areas, right? So when the cyclone hit, it does a lot of destruction. So how it can do the destruction? It has the energy, right? So we need to find a way to convert that energy into useful way. So small tide waves, we can say, yes, like this. Yes, tide waves, yes, we can convert those, but we do not find, it's not possible, at least right for now, to convert the cyclone's energy, because cyclone is a very destructive, destroying thing, right? So to convert that energy, it is not going to be easy for us, right? Then wind, also we know wind, or you can say that what we have, no, very large speed winds are also there. Those are also destructive, right? Those can also destroy a lot of property, right? So wind is also destroying, but we can use those in a useful way also, like turbines. Right here you can see turbines are there, and we can use those in the useful energy. So yes, so what are the non-conventional? Most probably they are not going to end, and they are not polluting anything, right? Solar energy, we already have talked a lot about the solar energy, and you know everything about the solar energy, right? So there is nothing new to talk in that. Then hydro means related to water. Tides we have seen. Geothermal heat. Geothermal heat, we can get the heat from the inside of the earth, right? Then biomass, biogas, we can say. Those are the non-conventional energies, right? And all these sources, you can say, are renewable sources, right? So this energy is never going to end. Tides are always going to be there. Then winds are always going to be there. Sun is always going to be there, right? So those are the energies. Do not cause environmental pollution. This is the very important part. That they actually do not cause any air pollution. Okay. Then, so example of non-conventional, we already know that solar energy is one of the example. Then wind energy, these are the big turbines. You must have seen these turbines. Mostly these turbines are in the free places, not in the, you cannot see this in our cities, right? Near the building. Why? Because wind must flow very naturally there. Now, in cities near the building, there is not a lot of wind. There is obstruction of the wind. Right? So those are very big fans are there, and you can imagine that even we cannot even rotate our normal fan if there is no light, right? So to rotate this bigger fan, the energy, that is wind energy, must be very high, right? Yes, so wind have a lot of energy in themselves. So when they are flowing, they are actually rotating these fans and giving us some energy. Okay. Then let's say water. When we say water is also giving us some energy. So what you can do, actually when we want to create the electricity, we have to rotate this turbine, we can say. So either wind can directly rotate this turbine, and this turbine actually are connected to, let's say, AC generator somewhere. You must have heard something. There are big magnets are there, and this coil is there, and that coil, the main part is when we rotate the turbine, this coil is going to rotate, and that rotating coil is going to generate you the electricity, which is alternating current. Actually, you must have heard that in the electrostatics lecture, right? Alternating current. So here wind is going to rotate that coil, turbines, and ultimately turbine will rotate the coils. We know that part, right? Therefore, we are getting the alternating current. what the water can do, right? So consider, anyway, if you want to rotate the turbines, so these are the turbines, right? So now if either you can use the wind or use the waterfall like this, right? So if the water falls like this turbine is going to rotate, and once the turbine rotates, we know that we are going to get our electrical energy, right? Then so these are the different types of the, we can say, non-conventional energy. This is our geothermal energy. We can also take it out from the inside of the earth. Okay, then so these are the non-conventional energies. Remember, non-conventional means we can also call them as green energy. Those energies are not going to create any pollution. Okay. Now let's talk about the conventional sources. Conventional sources means normally we use these types of energy. Normally we don't use the water energy, right, in our home. Nobody use the water energy. Nobody use the solar energy. Sometimes we do use the solar energy, but we never use the wind energy. So therefore, we are calling them non-conventional energy. So conventional means what? What? Which energy actually we use? We use the electrical energy, but the electrical energy is anyway converted energy, right? So what are the original sources, natural sources of the conventional sources? We can say petrol. Petrol is because of the oil, we can say. So oil reserves are actual the original natural sources, we can say. Natural gas which we use in the cylinders, LPG or CNG, like those. Even the cars also run on LPG or CNG, right? So those are the natural sources. This is the coal. Coal is the fossils. Fossil fuels, you can say. So these are some conventional sources of energy or fossil fuels, right? Now let's talk one by one. Let's talk about the coal. So yes, coal is obviously gives you the thermal energy if you burn the coal, and but there are a lot of coal mines are there, right? Even in India, you can see Maharashtra have the coal mines there, and Madhya Pradesh, Uttar Pradesh. So there are many coal mines are there, right? Obviously, you must have seen this type of coal mines in the movies most of the time, right? So it's a very dangerous camp, right? Obviously, you would not like to work there in the coal mines, right? So those coals, we can take out those coals, and then that coal, after burning, we can get the energy. Even some in trains, initially in the old days, there was a steam engine. Steam engine uses the coal as the fuel. We have to burn that coal in the train, then only we can run that train, right? So this is also the one of the important, we can say, right? Important source. Then oil. Now our oil is a very good energy, we can say, and most of the countries which do have the oil reserves are normally known as the rich countries. Why? Because this oil, everybody in the world needs the oil, right? So so oil actually procured by the this kind of machine, you can say, right? And we can use those as oil. So which countries are the major producers of the oil, right? So here they have given you the oil revenue in billions of dollars in 2018, right? So Canada, you can say Canada had to 66.9 billion. So this sold the oil of worth rupees 66.9 billion. Very big amount, right? USA also has oil mine, 47 point oil reserve, we can say 47.2 billion oil this sold to the world, right? Here you can see some countries, like Iraq, Iran, Saudi Arabia, UAE, Dubai, Kuwait. So all those countries have those oil resources, oil reserves, right? Therefore, those countries are very rich, right? You must have heard the many big buildings are there, right? So those countries have actually also have done a lot of improvement, right? So infrastructures are very good in those countries, right? Because those countries have all oil reserves, right? Russia have oil reserves, right? You can see 129 billion dollars. So it's a very big amount. They sold those much of amount. They got the revenues, profit from those. We can say oil. Okay. So Saudi Arabia, Iraq, Iran are good. Nigeria, Angola, Kuwait, right? So all those countries have the oil reserves, and all other countries, right? Like Australia don't have anything. South America don't have anything. Here uh, Asia don't have anything there. Africa don't have anything, right? Like that. So this is the oil reserves, we can say. Then let's talk about the natural gas. Natural gas also, those are found from the earth, right? So we have to procure those natural gas. We do use the natural gas in our cylinders, LPG, and etc. Right? So similar to oil, you can say natural gas is also procured from the earth. Okay, so these are the sources, fossil fuels. Why we are calling them as a fossil fuels? So when we burn actually those fuels, the air it gets polluted, right? So obviously we don't like those. Those are not good, but their efficiency is very good, right? Like this, why we use the petrol petrol is made up of oil, right? And why we use the petrol in our cars, not the solar energy? As I said, solar energy is not a constant source which will give you the continuous energy, right? Consider if there is a rainy season, what will your car will do, right? So that's not very good for us. So even though solar is a green energy, pure energy which do not pollute, still we are mostly dependent on this oil, right? So oil is not only means by we can say petrol, diesel, right? Even our cooking oil is also the refined or different form of oil. So this is the main oil which these countries use to whole world, and then we convert those oil into usable forms, right? So petrol, diesel, cooking oil is different, other oils are different, right? So all those things. Similarly, natural source, natural gas we can use. So all this coal, natural gas, then oils are our, we can say, non-renewable sources. Why we are saying non-renewable sources? Because after some years, yes, these are going to go have some end, right? So coal is going to get finished. Natural gas, there is limited amount of natural gas. Oil is limited amount of oil in earth, right? So unless once they end it, then we don't have any other option. We have to depend on all the green energies, right? So obviously scientists are doing some research how we can actually get the consistent source of the solar energy, let's say, or how to save the solar energy, how to use the solar energy to drive the cars, right? Like that. So it obviously going to take some time. So till then, we have to save these fossil energies, right? And also they are not also good for the our air or pollution. They do the pollution, we know that. And the very big reason for that, because of that, we get is the acid rains. So because of these fossil fuels, when we burn them, when we use them, we actually polluting the air, right? So because of that, you can see these are the many manufacturing unit. So what they are doing, these are the oxides of nitrogen, carbon dioxide, we can say, right? Or sulfur. Those oxides are, we are actually polluting the air with those oxides, right? So here you can see something. So SO2, sulfur dioxide is there, nitrogen dioxide is there, right? They gets combined with the water particles in the air or oxygen in the air. And what they are producing? Sulfuric acid, nitric acid in the air. Now you can imagine if except the normal rain, if these oxides or these acids are there in the rain, those will be very dangerous, right? Now this is not the common occurrence actually, right? We do get the normal rain nowadays, but yes, acid rain is one of the things there. Even on the Taj Mahal also, you can there was some years back, there was acidic rain, and that acidic rain actually turned that Taj Mahal's marble. Now we know the Taj Mahal is made up of what? Marbles, right? That marbles get reacted with these acids, and that marble become the, some powdering material was created because of these acids and the marbles, right? And the Taj Mahal was would look like a yellowish instead of white, right? So now you can imagine that if the Taj Mahal is yellow, becomes yellow, then nobody will go there to see that Taj Mahal, right? It will lose its beauty. So that acid rains are not good, not even for the animal, but also for our human beings. It is not good if you go into the acid rain. If in the rain there is more percentage of sulfuric and nitric acid, it is not going to be good, right? So who is responsible for that? Pollution. Pollution means fossil fuels. Who are using the fossil fuels? Us only, right? So what we have to do? We have to stop or minimize our use or dependence on those fossil fuels, and obviously we should try to minimize the pollution, okay, to stop the acid rain. Okay, good. So this is the whole theory part of our today's session. So we just took the introduction of all those energies and the fossil fuels. Okay, let's try this small questions on this. So first one is which of the following is non-renewable source? Non-renewable source means we cannot it will end, obviously, right? So what we can say, sun is never going to end, wind is never going to end, wood, as long as trees are there, wood is not going to end, but fossil fuels, yes. So fossil fuel will be our answer. It is not a renewable source, so it is a non-renewable source, we can say. Simple. Next, acid rain happens because of, so obviously we studied it is because of the our pollution. Who does the pollution? Humans. Using what? Fossil fuels means coals, oils, petrol, diesel, natural gas, etc., right? And those fossil fuels actually releases the oxides of carbon, nitrogen, and sulfur. We have seen in this diagram, right? Here you can see SO2, NO2, CO2 are there. So these are the oxides of carbon, nitrogen, and sulfur, and they get reacted with what? Oxygen and water particles in the air, and creates the dangerous, harmful sulfuric acid or nitric acid, like that, which is not good for us. Yes, so this is our answer. Burning the fossil fuels, and which creates the oxides of carbon, nitrogen, sulfur. Then fuel used in thermal power plants is, right? Obviously, we use the fossil fuels nowadays. Water energy, biomass energy, biogas, or solar energy is not enough for right now, right? So we use the fossil fuels there. Simple. Okay. So this is the whole thing for today. So we are going to stop here today. If you do have any questions, so very basic chapter, right? A very basic theory chapter is there. You must have seen that there is no numerical in this chapter. Okay. So I have completed the whole portion or syllabus of the physics. So this chapter is very easy for you guys. So that's not a big deal. So still, if you do have any questions, please put them into the forum so we can solve those. Okay. Anyway, so we'll stop here. Thank you very much. Have a nice day.